So, normal curly wing flies, CY plus, CY plus. We have normal flat wings. If you are heterozygous, plus, minus, you have curly wings. So, you're heterozygous and you have curly wings. Is curly a dominant or a recessive trait? Curly is a dominant trait, correct? Because it's a mutant version that is being expressed in the heterozygous condition. And then, little cy is probably curly. I'm saying probably curly. The reason I'm saying it's probably curly is because when you look at wing shape, the curly mutation is dominant because of the heterozygous condition you get curly wings. Flat wings is recessive. When you look at viability, are the flies alive or dead? These flies are alive, which are normal wings. These flies are alive. Heterozygous curly is alive. But homozygous curly, these flies are dead. So at the level of viability, curly is a recessive mutation. At the level of wing shape, curly is a dominant mutation. So how do you study this? How do you know these flies are dead? What would happen? Well, let's do a cross. Let's take a heterozygous curly male, cross it to a heterozygous curly female. And we're going to look at the live progeny. Okay? We're going to look at the progeny of the flies once the flies have gone through larval stage, gone through the pupal stage, and then they form flies. That's when you look at the progeny. So, we're going to analyze the presence of curly versus non-curly in the progeny. Now, what you find when you do this analysis is you get a ratio that's 2:1, not 3:1. Remember I told you curly is dominant to flat wings. So when you take a heterozygous curly wing fly cross to a heterozygous curly wing fly, prediction would be 3 out of the 4 would be curly and 1 out of the 4 would be flat. What you get is 2 out of the 3 is curly and 1 out of the 3 is flat. The ratio is not 3/4 to 1/4, but 2/3 to 1/3. So how does that work? Okay. So here is your heterozygous curly fly, male, crossed with heterozygous curly female. What you get are little CY, CY plus, plus, plus. Alright? Is this clear? Heterozygous to heterozygous, you get 1:2:1 genotype ratio. These plus pluses are normal wing. These are curly wings. These flies never come out of the pupa. They're dead. So you get a ratio 2 curly to 1. And so the ratio is altered. It's not a 3:1 ratio, but it's a 2:1 ratio. A 2:1 ratio indicates that the curly homozygous condition is lethal. And you've lost it. So a 2:1 ratio of a heterozygous to a heterozygous is an indication of lethality. So at the level of all of the flies, we would see this ratio. But at the level of looking at just the live flies, counting live flies, the ratio would be 2 out of the 3 live flies would be curly and 1 out of the 3 live flies would be flat. And so you would calculate and determine what curly does based on this ratio. Phenotype of survival, 3 alive, 1 dead. Phenotype of curly, 2 curly, 1 dead. This is the reason. The reason is this entire class of flies are missing from the progeny. They disappear, and so you don't find them in the progeny class. same thing happens in mice. The agouti-colored mice, it's a coat color gene. Gene involved in coat color produces these kind of yellowish brown colored mice. When you do a cross of a heterozygous agouti to a heterozygous agouti, you find there is a homozygous recessive allele. So this entire class is missing, and you get 2 yellow, 1 black. So the same thing happens with this. So the ratio is a 2:1 ratio of live mice. This class is not formed, and so you don't see it. Now, if you were to go into the mother and look at the little pups that were not born or that were aborted prematurely, you would find that those pups would be this genotype. Any questions about any of these topics? You guys have been very quiet today. I'm surprised. I thought you would ask a lot of questions, but think about it. If you have any questions, Thursday's lecture you can ask me again. All right? We've gone through this quite a bit. I was shocked how quickly we've gone through this. But, okay, we'll carry on with